Okay, sorry about that. For some reason, it magnified on us, but we're back to regular size. So back to talking to us about slopes of tangent lines. So I was going to say is the slope of the tangent line and the rate of change of the curve at that particular point are equivalent to each other. So it says find the equations for tangent lines to the graph of f of x is equal to x squared minus the square root of x. In other words, go ahead and find my slope generator, which is my derivative, and I'll plug in the different x values to get the different slopes at all the different points, and then I'll have a point and slope that I can use to come up with the three different tangent lines. So then we need f prime of x first. So f prime of x will be equal to derivative of x squared is 2x. Now I've got x square root of x, which is x to the 1/2 power. So it's going to be minus 1/2 x to the negative 1/2 power, because 1/2 minus 1 is negative 1/2, which will be 2x minus 1 over 2 to the x to the 1/2, which is just the square root of x. All right, so at the first point, which is 1, 0, we're going to go ahead and find the slope of our tangent line, which is the same thing as our derivative evaluated our x value, which is 1. So 2 times 1 minus 2 over, it's going to be 1 over 2 square roots of 1. So 2 minus 1/2 will be 3/2. That means now that I have a point and a slope. And remember, point slope form is derived from the formula for slope just by multiplying both sides by x minus 1. So it ends up being y minus y sub 1 is equal to m times x minus x sub 1. So when I'm plugging in values, I have y minus y sub 1 is 0 is equal to the slope, which we've determined to be 3/2 when x is 1, times x minus this 1 here. So it's going to be y is equal to, when I distribute 3/2, x minus 3/2 for the first one. Okay, second point is 414. So at this point, because my curve is continuously changing, the slope is going to change. Our slope generator is our derivative, so the slope there for the tangent line will be f of 4, which is going to be 2 times 4 minus 1 over 2 times the square root of 4, which is going to be 8 minus 1/4, which is 7 3/4. Mixed numbers are more difficult to work with than improper fractions, so let's go ahead and convert this back to a fraction. It says I have 7 wholes and 3/4. Well, each whole is broken into 4 pieces, so 7 of them, 7 times 4 each, will be 28, plus the 3 extras is going to be 31. So now this is 31/4 as a improper fraction. So then y minus y sub 1 this time is 14. Will be equal to m, which is 31/4, times x minus x sub 1, in this case is 4. Let's distribute and let's add the 14, so it'll be y is equal to 31/4 x minus 31 over 4 times 4, the 4's cancel, is just 31, plus the 14 from the other side. So this is going to be equal to 31/4 x, and 14 minus 31 will be negative 17. Minus 17. We've got one more. The coordinates there are 9 and 78. So again, I need the slope first. Remember to put that little mark up there, that prime mark that indicates that you're using the derivative there. I left that out last time in my notation when I was evaluating for 4. So the derivative evaluated at 9 will be equal to 9 squared, 2 times 9. I'm using this right here, so it's 2 times 9 minus 1 over 2 times the square root of 9, which is going to be equal to 81 minus 1/6. Okay, so that's going to, okay, 2 times 9, 9 squared is 81, 2 times 9 is 18. 18 minus 1/6, because 2 times 3 is 6. So 18 minus 1/6 is going to be 17 and 5/6. All right, again, I want to use an improper fraction. I don't want to use this mixed number. So we have to multiply 17 times 6 because there's 6 pieces in each one of those 17 holes. So 17 times 6 will be 102, plus the other 5 will be 107. 6. Now we can go ahead and use our point slope form. So y minus y1, which is 78, is going to be equal to the slope, 107 over 6, times x minus the x coordinate, which is 9 in this case. So we're going to distribute, we're going to bring the 78 over. So y is equal to 107 over 6x. Now, when we multiply 107 over 6 times a 9, let's reduce. So 6 goes into 3 goes into 6 twice, 3 goes into 9 3 times. 107 times 3 is going to be 321 halves plus the 78. So if I want to turn 78 into halves, I have to multiply it by 2 over 2. 2 times 78 is going to be 156. Okay, so if we need to do a little arithmetic here, y is going to be equal to 107 over 6x minus, let's see, if we want to make 321 out of 156, we're going to have to add 165. So 165 over 2. Okay. Slopes, problems like these, by the way, can be found on page 146, numbers 57 through 60. Slope of a horizontal line is equal to 0. Use this fact to find horizontal lines. Horizontal lines are flat. Okay, they have no rise, they only have run, so the y's are always the same. So the difference in the y's in the numerator is always going to be 0. 0 over anything is 0, so that's why all horizontal lines have a slope of 0. So the first thing you're going to do is find the derivative of your function. Then you're going to set that one equal to 0 and solve it, disregarding any extraneous solutions should you come across them. Once you set this equal to 0, you'll find all the different places, because you could have multiple places where your tangent line is horizontal. So find the points of the graph. Y is equal to 5x squared minus 3x plus 8, at which the tangent line is horizontal. If none exists, state that. So 5x squared minus 3x plus 8, we know the graph of that is a parabola, and there should be one horizontal line there. It has that peak, or that bottom, or that top, where it does this. That should be the only place where your tangent line is horizontal. So let's go ahead and do the derivative, see if we can find out where that happens. So dy dx is going to be equal to derivative of 5x squared is 10x. Derivative of negative 3x will be negative 3. Derivative of 8 will be 0. If I set 10x minus 3 equal to 0, I would add 3. This is linear, so we'll simplify this late divide. Divide by 10. The x-coordinate at which the tangent line is horizontal is going to be 3/10. If I want to find the y-coordinate, I'm going to have to plug it into the original equation because I want the point on the original graph. So y is going to be equal to 5 times 3/10 squared minus 3 times 3/10 plus 8. So now 3 squared is 9, 9 times 5 is 45. 10 squared is 100, minus 3 times 3 is 9/10, plus 8. Let's reduce this one. So common factor 5. 5 goes into 45 9 times and into 120 times. LCD in this case is going to be 20. So to make 9/10 into something over 20, I'm going to have to multiply by 2 to make that 20, so 2 to make this 20. And really this is 8 over 1. So in order to make 120, we're going to multiply by 20 and by 20. So this is going to be 9 over 20 minus 18 over 20 plus 16 over 20, which is going to be equal to 9 minus 18 is negative 9. Negative 9 plus 16 is positive 7, so 7 over 20. Ordered pair, 3/10, 7/20. That's the point at which the tangent line is horizontal. Here's another one. find the points on the graph of y is equal to negative 1/3 x cubed plus 6x squared minus 11x minus 50, at which the tangent line is horizontal. If none exists, state D&E does not exist. Okay, so first thing we need to do, find the derivative, dy dx equal to negative 1/3 x cubed. 3 times 1/3 is going to be just 1, so this will be a negative. X raised to 3 minus 1 will be 2, plus 2 times 6 is 12, minus 1 will be just x to the 1. Derivative of negative 11x will be negative 11, and derivative equal to 0.
Okay, this guy is not linear, this one's quadratic, so we're either going to factor and use zero product property, or we're going to use quadratic formula. I like to factor. I do not like to deal with a leading negative, so we're going to multiply through both sides by negative 1. That's going to change the sign on all the signs on the left, and it's going to remain 0 on the right, so we end up with x squared minus 12x plus 11, which is equal to 0. Let's factor. Leading term is x squared, so that means first terms in parentheses are x and x. Last term is plus 11, so same sign. Middle term's negative, so both negative. Only factors of 11 are 11 and 1, so if 11 and 1 do not work, this is prime. Let's check our inners and outers. Inners are negative 11. Outers are negative 1. Negative 11 plus negative 1 is negative 12, so we're good. Which means x minus 11 equals 0 yields x is equal to 11 as 1 point. X minus 1 equals 0 yields x is equal to 1 as a second point. So this particular graph has 2 tangent lines. I need the y coordinates that go with these. So if I do y evaluated for x is equal to 1, negative 1/3 times 1 cubed plus 6 times 1 squared minus 11 times 1 minus 50. Again, I went back to the original equation because I want physical points on the graph itself. So this is going to be a negative 1/3 plus 6 times 1 is 6 minus 11 minus 50, which is going to be equal to 55 and 1/3, negative 55 and 1/3. I would go back and check that with your calculator. So the ordered pair will be 1, negative 55 and 1/3. We evaluate for x is equal to 11. I've got negative 1/3 times 11 cubed plus 6 times 11 squared minus 11 times 11 minus 50, which is 111 and 1/3, leaving you with an ordered pair of 11, 111 and 1/3. Okay, problems like this can be found in your textbook on page 146, numbers 61 through 78. Occasionally, some algebras need to manipulate a function into a form in which the rules that we just learned in this section can be used, because right now we cannot deal with this product of two binomials or this rational expression or even this radical. Well, we could deal with this one. Not actually, no. We'd have to do some manipulation here, and we can't deal with them quite yet with what we have. So then, but there are things we can do. So we can FOIL this, and then we can go ahead and use the sum and difference rule. So let's do that. If I've got product of a sum and a difference, it turns out to be a difference of two perfect squares, because x times x will be x squared. Product of the outers would be plus x. Products of the inners will be minus x. They're a pair of opposites, they're going to cancel. Negative 1 times 1 will be negative 1. So this is just x squared minus 1. So then dy dx will be equal to derivative of x squared is 2x, derivative of negative 1 is 0. So the derivative of this is just 2x. Now with these quotients, when you add and subtract fractions, you have a common denominator and then you combine the numerators. So we're going to use this and work backwards. We're going to split this back into 4 separate fractions, each with a common denominator of x squared. So this will be equal to x to the 5th over x squared minus 3x to the 4th over x squared plus 2x over x squared plus 4 over x squared. Now let's go ahead and simplify each one of these. I can cancel 2, leaving me with 3, so I've got x cubed, minus, cancel 2 of these, leaving me with 2, so it'll be 3x squared, and cancel 1, leaving me with 1 here, so plus 2 over x, and there's no reducing to be done on the last one, so 4 over x squared. And let's take the derivative. Remember, we're going to consider this to be 2 times x to the negative 1, and this one's going to be 4 times x to the negative 2. So our dy dx will be equal to 3x squared. 2 times negative 3 makes it negative 6x. Now remember, this is 2x to the negative 1, so negative 1 times 2 will be negative 2. Negative 1 minus 1 is negative 2, which goes in the denominator, plus negative 2 times 4. So actually, let's make this a minus. Plus minus is a minus. So it'll be negative 2 times 4 will be 8. Negative 2 minus 1 will be negative 3. Okay, that's the derivative of that particular one. Now, for the radical, y is equal to the square root of 7x. If you remember the rules of radicals, if you have a product, only a product, not a sum or difference, inside your radicand, it comes from the product of 2 radicals that have the same index. So in other words, this is equivalent to the square root of 7 times the square root of x. Square root of 7 is just an irrational number, so it's just the coefficient. We're going to leave him the way he is. The square root of x we're going to have to use as x to the 1/2 power. Now we can do our derivative. Dy dx will be equal to 1/2 times the square root of 7 is the square root of 7 over 2 times x to the negative 1/2 power. So square root of 7 over 2 square roots of x. If you go back to your college algebra and rationalizing denominators, back to rules of simplest form, you're technically not supposed to leave square roots in the radicals in your denominator. You're supposed to rationalize them. In order to rationalize the square root of x, I would have to multiply it by the square root of x. That way, the square root of x squared would end up being just x. But if I do that in the denominator, I also have to do that in the numerator. That way I'm multiplying by 1, which will change its appearance, but not its value, because 1 times anything is itself. So square root of 7 times square root of x is going to be square root of 7x. Over, again we said square root of x times itself would be the square root of x squared. Square and square root cancel, so it's just going to be 2x. Problems like these can be found on page 148 in your textbook, numbers 103 through 110.